Imagine two galaxies, massive islands of stars, gas, and dust, on a collision course in the vastness of space. Their dance of destruction is breathtaking, creating shockwaves of star formation and reshaping the universe as we know it. These cosmic collisions are not rare, they're the architects of galaxies, including our own Milky Way. Thanks to the Hubble Space Telescope, we've been able to witness these galactic mergers like never before. Hubble's powerful lens captures every detail from explosive starbursts to intricate tidal tails, revealing how the universe's most violent events drive the creation of new stars and reshape entire galaxies. Join us as we explore the spectacular science behind violent galactic mergers and the chain reaction of star formation they ignite. From the birth of stars to the evolution of galaxies, we'll uncover the secrets hidden in Hubble's breathtaking images. The universe is a theater of immense and dramatic cosmic events, and one of the most fascinating spectacles involves galactic mergers. When two or more galaxies collide, they trigger extraordinary changes, including the birth of new stars, the redistribution of gas and dust, and the formation of entirely new galactic structures. Among the many tools astronomers use to study these phenomena, the Hubble Space Telescope, HST, has been instrumental. Its advanced imaging capabilities provide unparalleled views of the intricate details of galactic mergers, revealing how these events drive a chain reaction of star formation across the cosmos. Galactic mergers occur when two or more galaxies pass close enough for their mutual gravitational forces to interact. Unlike typical collisions in everyday life, galaxies are mostly empty space, so their stars rarely collide directly. Instead, gravitational forces redistribute gas, dust, and stellar orbits, leading to profound transformations. Such interactions often result in dramatic changes. The compression of gas clouds during a merger can lead to rapid and prolific star formation, a phenomenon called a starburst. Merging galaxies often transform into entirely new structures, such as elliptical galaxies or peculiar irregular shapes. Central supermassive black holes in merging galaxies can become active, emitting enormous energy as they accrete matter. The Hubble Space Telescope has captured detailed images of numerous galactic mergers, shedding light on the dynamic processes at work. Thanks to its high-resolution imaging and ability to observe across multiple wavelengths, Hubble has been able to dissect these violent events in exquisite detail. Observations in ultraviolet, visible, and near-infrared light have been particularly valuable for studying the star-forming regions and the distribution of gas and dust. Notable discoveries made with Hubble include: one of the nearest ultra-luminous infrared galaxies, ARP 220, is a result of a galactic merger. Hubble's images revealed intense star formation concentrated in its central regions, fueled by large reserves of molecular gas. This iconic pair of merging galaxies showcases bright star-forming knots where gas and dust have been compressed. Hubble's observations highlighted the chain reaction of star formation triggered by the collision. This compact group of galaxies demonstrates how gravitational interactions during a merger can trigger both star formation and violent outflows of gas. Star formation in galactic mergers is often compared to a chain reaction. The collision of gas clouds within merging galaxies creates shockwaves, compressing the gas into dense pockets where gravity takes over, leading to the birth of stars. This star formation can spread like wildfire through the galactic disk and into tidal tails and other disturbed structures created by the merger. Key observations from Hubble have provided insights into compression of gas during gravitational interactions is the primary driver of star formation in mergers. Starbursts often peak early in the merger and can last for millions of years before gradually subsiding as the gas supply diminishes. Star formation can occur in both the central regions of the galaxies and in the extended tidal structures flung out during the collision. Galactic mergers are not just local phenomena but have profound implications for cosmic evolution. Most large galaxies, including our own Milky Way, have experienced mergers throughout their history. These events are fundamental to shaping the structure and content of the universe. Some implications include: mergers can transform spiral galaxies into elliptical ones and contribute to the growth of galactic halos. The merging process funnels gas into the central regions, feeding the black holes and triggering active galactic nuclei. Star formation during mergers contributes to the enrichment of the interstellar medium with heavy elements. While Hubble has been invaluable, the upcoming generation of telescopes promises to deepen our understanding. The James Webb Space Telescope, JWST, launched in December 2021, is poised to complement Hubble's observations with its infrared capabilities, penetrating dusty regions to reveal hidden star-forming activity. Additionally, ground-based observatories with adaptive optics and radio telescopes like ALMA, Atacama Large Millimeter, Submillimeter Array, provide complementary perspectives on the cold gas and dust reservoirs fueling star formation. The Hubble Space Telescope has opened a window into the violent and awe-inspiring world of galactic mergers, offering a front-row seat to the cosmic drama that shapes our universe. Its observations have illuminated the processes that lead to the birth of new stars and the transformation of galaxies. As astronomers continue to explore the heavens with even more powerful instruments, the story of galactic mergers and star formation will undoubtedly reveal new chapters, enhancing our understanding of the dynamic and evolving cosmos.